All right, today we're going to start our factoring unit. We've added, subtracted, multiplied, and divided polynomials to get what we would call a simplest form answer. Now we're going to take and reverse our answers back into a multiplication problem. Okay, factoring is reversing the multiplication process. But before we do that, let's go ahead and review a little bit with our multiplication. If you look at the top of your worksheet, you actually have a warm-up right here. It's asking you to simplify the following polynomials. And if you'll notice, we have multiplication. So pause the video right now and work these three problems out, and then mash play, and I'll work them out, and we'll make sure that you're still doing a good job with your multiplication. So pause the video now. All right, welcome back. Now let's look at number 1. We have a monomial a multiplied to the binomial 3a plus 7. So let's use the distributive property. We have a times 3a. Remember, when you multiply with the same base, which would be those a's, you add your exponents. 1 plus 1 is 2. And then a times positive 7 is just positive 7a. Put the number before the variable. And what this is a simplified polynomial. It's in simplest form. Let's do the same thing here. We'll multiply to m squared, 6m, and negative 1. Negative 2 times 1 is negative 2. M times m to the second, when you multiply with the same base, add your exponents. 1 plus 2 is 3. Negative 2 times 6 is negative 12. M times m, when you multiply with the same base, add your exponents. And then finally, negative 2m times negative 1. Negative 2 times negative 1 is a positive 2, and then the m will just come along for the ride. So this is in simplest form. Let's multiply the third one. 4 times 1 is 4. Okay, we have x to the third times x to the second. When you multiply with the same base, add your exponents. 3 plus 2 is 5. And then we've got that y we're just going to stick on the end. 4 times negative 2 is negative 8. We have x to the third. We don't have another x, so we'll put that on there. Then we have y times y. When you multiply with the same base, add your exponents. So we get 4x to the fifth y minus 8x to the third y squared. And these polynomials are now in simplest form and multiplied out. So now what we're going to do is we're going to start our factoring, which is going to take these answers in simplest form and go back to what we call a factored form, which is going to be the original multiplication problem. So we're going to go from the answer back to the problem when we factor. So here's an example, simplest form, which is what we have here. Everything's all multiplied or sometimes divided out, and we're going to go back to what we call a factored form, which is a multiplication or a division problem. Okay, so polynomials that cannot be factored are called prime. That means we cannot factor them in any way, shape, or form. There's several factoring methods. The approach depends on the polynomial. What you should always do, no matter what type of factoring that you're doing, is always take out a GCF first, okay? And then complete your factoring in any other method. So, steps for factoring a GCF. Identify what the GCF is. So look at all your coefficients and find a greatest common factor. Then look at the variables. The variable must be present in all terms in order to be a GCF. And what you do to find a variable GCF is always look at the smallest exponent. And then you will divide by the GCF, and you can always check it by using the distributive property. Okay, let's look at number 1. We have the simplest form, 3x plus 12, and we want to factor this using a GCF. So first, look at your coefficients. You have 3 and 12. Now, the greatest common factor between 3 and 12 is 3. But if you don't know that off the top of your head, you need to list the factors of 3. Factors are the numbers you multiply together to get 3. 1 times 3 is 3. And then list the factors of 12. 1 times 12 is 12. 2 times 6 is 12. And 3 times 4 is 12. Now, they're always going to have that 1 in common. but this set of numbers also has a 3 in common. So that tells me my greatest common factor is actually 3. Now notice the first term has an x, but the second term does not have an x. So if you do not share a variable, you cannot use it as a greatest common factor. So your greatest common factor for 3x plus 12 is simply 3. Once you find your greatest common factor, divide by it. Exactly what we did yesterday, division by 3. So put the 3 on the outside of your parenthesis. Whatever you divide by will always go on the outside. 3x divided by 3 is 1. 12 divided by 3 is 4. So we end up with 3 times x plus 4. This is my factored form. 3 times x plus 4. I can go over here to the side and I can use the distributive property. And I should always go back to my original answer. That's a way to check your work. This is the factored form. This is what I'm looking for. This is checking my work. Let's look at number 3. I have 8m plus 36n. Let's take my 8 and my 36 and let's figure out what my GCF is. We have 1 times 8 is 8 and 2 times 4 is 8. 1 times 36, 2 times 18, 3 times 12, ran out of room, 4 times 9, and 6 times 6. If you have a double like 6 times 6, only write it down 1 time. So here we see that we have a 1 in common, a 2 in common, a 4 in common. We don't have anything else in common, so my GCF here is 4. So I'm going to divide this polynomial by 4. Now look at your first term. Do you see how it has an m, but the second one doesn't? The second one has an n, but the first one doesn't. So you do not have a variable GCF, you only have a number GCF. So we're going to divide by 4. Put your GCF in front of your parenthesis, and whatever you divide and get will go inside your parenthesis. 8 divided by 4 is 2. 36 divided by 4 is 9. And we get 4 times 2m plus 9n. Now you can go to the side and you can FOIL this, or not FOIL, distribute this out. 4 times 2 is 8, and 4 times 9 is 36. And you see that you go right back to the original answer. And remember, this is just a way to check it. This is your factored form. Okay. Let's look at the next page, number 5. We've got 6a squared plus 27. So 6 and 27 are my coefficients and my constant. Let's list the factors of 6. Let's list the factors of 27. And you'll see that they have a 3 in common and a 1, but 3 is your GCF. This is the only variable, so you cannot take out a variable if they don't both have it. Both terms have to have an A in order to take out an A. So let's put the 3 on the outside. 3 will go into 6 2 times. 3 will go into 27 9 times. And that's my factored form. Number 7, I've got 21 and 3. 1 times 21 and 3 times 7, 1 times 3. Hope you've noticed every time they've had a 1 in common, and they always will. And then the other number here is 3, so that's my GCF. So I'm going to divide by 3. Now this one has a C. This term does not have a C. Oh, but look at the D's. They both have a D. Since both terms have a D, and they're both D to the first power, my GCF will be 3D. So put your GCF on the outside and divide. 21 divided by 3 is 7. Got a C, but what happens to those D's? They cancel out, don't they? Then negative 3 divided by 3 is negative 1, and the D's cancel out. You can't leave it blank. So 3D divided by 3D is 1. Opposite signs make it a negative 1. Because you've got to be able to take 3D and multiply it times 7C minus 1 and get back to your original problem. 3 times 7 is 21. D times C, alphabetical order. 3D times negative 1 is negative 3D. Okay, and look, you got the original problem. So this is a check. This is your factored form. Number 9. Let's take 15 and 30 and find the GCF. 1 times 15 is 15. 3 times 5 is 15. 1 times 30. 2 times 15. 3 times 10. 5 times 6. So we've got a 1, a 3, a 5, and a 15 in common. So my GCF is 15. Now I have a squared and a. To figure out a GCF with your variables, it is always going to be the one with the smallest exponent. Because see, a squared is a times a, and then a, they only have one a in common. So that's your greatest common factor. So 15a, and they both have a b, b to the first. So 15ab. 15 divided by 15 is 1. 2 minus 1 is 1, and the b's cancel out to 1. So we have 1a. Negative 30 divided by 15 is negative 2. A and b divide out to 1. So we get 15ab times a minus 2. Now looking at number 11, you see that we have coefficients of 1. Well, if it's 1, then it's 1, okay? You don't have a greatest common factor number-wise to worry about. But both of these terms have an a. They do not both have a b. So my GCF here is a. A divided by a is 1, or 1b. Negative a divided by a is 1. Opposite signs make it a negative 1. Number 13. Okay, we have 5 and 13. Well, these two look very suspicious to me. Both of these numbers are prime numbers. When you have two prime numbers, their GCF is automatically 1. So this one has an x, this one doesn't. This one has a y, this one doesn't. So my GCF is 1. If your GCF all the way around is 1, this is not going to factor, so we call it prime. Number 15 jumps into 3 terms. Okay, so we have 2, 2, and 4. So that tells me I need to find the GCF between 2 and 4. So 2 being a prime number is 1 times 2. 4 is 1 times 4 and 2 times 2. Don't write the 2 down twice. Of course, they have a 1 in common, but they also have a 2 in common. So I know number-wise my GCF is 2. Now look at your x's. All 3 terms have an x. So we have x squared, x to the first, and x to the first. So x is going to be my GCF. All 3 terms also have a y. Y squared, and y. So that's going to be my y. So 2xy is my GCF. 2 divided by 2 is 1. 2 minus 1 is going to give me x to the first, and then y divided by y is 1. Now my second term, negative 2 divided by 2 is negative 1. X divided by x is 1. 2 minus 1 gives me y to the 1. Now my third term, 4 divided by 2 is 2. X divided by x is 1, and y divided by y is 1. So this is what I end up with. Number 17, I have 6, 14, and 10. 1 times 6 is 6, and 2 times 3 is 6. 1 times 14 is 14, and 2 times 7 is 14. 1 times 10 is 10, and 2 times 5 is 10. So all 3 of these have a 1 in common. All 3 of these have a 2 in common. Okay, so that means my GCF between all 3 of them is 2. So let's divide by 2. Notice all 3 terms have a y. The smallest exponent is y squared, so that's my GCF. So 2y squared goes on the outside. 6 divided by 2 is 3. 4 minus 2 is 2. 14 divided by 2 is 7. 3 minus 2 is 1. Negative 10 divided by 2 is negative 5. Y squared divided by y squared is y to the 0, which is 1. And 1 times negative 5 is negative 5. Number 19. In an effort to save time, I'm going to cheat a little bit. 14 and 28 have a GCF of 14. Now, all three of these do not share a G. You got a G here, but no G. So you cannot take out a GCF unless all the terms have that variable. Now, all three of them do share an H. H squared, H, and H. So my GCF is going to be 14H. Remember, with a variable, it's always the smallest exponent. So 14H, 14 divided by 14 is 1. G divided by nothing is G. And H squared divided by H, 2 minus 1, is 1. Next, 28 divided by 14 is positive 2. G divided by nothing is G. And H divided by H is H to the 0, which is 1. Then 14H divided by 14H is positive 1. Now, number 21, you've got a coefficient of 1, negative 1, and 5. If you have a coefficient of 1, that's automatically your GCF. But look at your variables. All three terms have an M. The smallest m is m to the first. All three have an n. The smallest n is n. So that's my GCF, mn. 3 minus 1 is 2. N over n to the 0, which is 1. Then bring down that minus sign. 2 minus 1 is 1. 2 minus 1 is 1. Bring down that positive 5. M over m is m to the 0, which is 1. 3 minus 1 is 2. And we're done. And on this bottom one, 35, 20, and 15 have a GCF of 5. All three of them have an A. The smallest A is A, but only this one has a B, so I cannot use B as my GCF. 35 divided by 5 is 7. 2 minus 1 is 1. Negative 20 divided by 5 is negative 4. A over A cancels out, leaving me with B squared. 15 divided by 5 is 3, and again, those A's cancel out. So that's the greatest common factor. Greatest common factor is always the first thing you should look for when you're factoring. So do the rest of these problems and send them in to me, and y'all have a great day.